Hello, professors and esteemed colleagues of engineering technology. My name is Brian Burridge, and this is a presentation of my senior project, the welding cart with fixture table. A sturdy work surface is essential for any welding project. The ability to mobilize the work surface and welder is essential for any shop. The ability to easily interchange a fixture setup is essential for improving productivity and quality of repeatable workpiece assembly. Research was conducted to get an idea of the variety of welding tables that currently exist on the market. This welding table provides a unique design for modular fixture welding tables that can adapt to different workpieces, but it's not a cart. And this product has a tabletop made of sheet metal, which includes elongated slots for the insertion of clamping tools, but it's not very sturdy. The ultimate goal of this product development project was to create an enhanced welding workstation for many levels of welding uses by combining a portable welding cart with a sturdy work surface that features an interchangeable fixture design. The primary objectives include design and produce a functioning prototype that is simple to be manufactured and assembled. Design the product so that all parts can be bundled and packaged for retail storage and shipping needs. Create a complete set of detailed working drawings required for manufacturing. And provide a structural analysis showing the product can safely support a minimum 500-pound load. The project began with the design phase using the 3D modeling software Autodesk Inventor, which was surprisingly similar to the NX program learned in computer-aided drafting. Once the best layout and connections were determined, the model was completed, and the bill of materials and detailed fabrication drawings were generated. The materials selected for the product consist of structural steel tubes, channels, and angles, along with some accessories made from 16-gauge sheet metal. This exploded assembly shows the three main welded components that are bolted together: the work surface top, the vertical legs, and the bottom tray. The accessories include a variety of fixture stops that can be bolted or clamped to the work surface, and the sheet metal components shown, which will hang off the sides of the table. The manufacturing phase began with making the sheet metal components. The parts were first cut from sheet metal stock with the CNC plasma cutter. And then the bends were formed on the gauge metal brake machine. The next step was to prep the parts for the welded components of the welding cart, which included the layout and drilling of the connection holes, punching the alternating slots in the work surface channels for the fixture table, and miter cutting the framing angles for the bottom tray with the jigsaw. After the prepping stage was complete, a quality check was conducted to verify all components were manufactured within tolerance as specified on the detailed working drawings. The welded components were then fitted and welded up using the gas metal arc welding process, or more commonly referred to as MIG welding. Prior to assembling, it was verified the product could be bundled and packaged into a flat box approximately 6 inches high to meet the storage and shipping requirements. The product was then assembled to verify the assembly process can be completed by one person in 5 simple steps. The assembly instruction was created showing the steps. Holes were strategically located in the vertical legs so they can be easily bolted to the bottom tray with the use of standard 2x4s. This assembly is then flipped for the attachment to the work surface, followed with the attachment of the caster wheels. The structural analysis of the product was conducted by multiple methods. First, the actual stress and deflection were manually calculated to compare with the material's allowable stress. Next, Autodesk Inventor's Frame Analysis Simulator was used to understand the structural integrity of the frame by viewing the behavior relative to the applied load. The design calculations in the simulated frame analysis confirmed the allowable stress of the framing components and shear stress of the bolts can withstand a load much greater than the tested value of 500 pounds, which only resulted a maximum deflection of less than a 1/16 of an inch. This was also confirmed with an actual physical load test by stacking 500 pounds of weight and measuring the deflection at the center of the frame. Although this test was not a very scientific method, such as using a transducer in a lab to measure the linear motion and strain, it did confirm the results of the manual calculations in the software's frame analysis, as well as the sturdiness of the product. This project offered many learning aspects throughout the process, such as designing for allowable stress, learning a new 3D modeling software, and gaining additional knowledge of MIG welding techniques and machine settings. The fabrication process was not difficult, but required additional time and care to maintain tolerances. This hands-on experience stressed the importance of utilizing jigs and fixtures for maintaining accuracy and repeatable precision. The goals of the project were successfully accomplished within budget and on schedule. By combining the mobility of a welding cart with a fixture table work surface, this easy assembled welding cart and fixture table offers an ideal solution for many welding project needs. So finally, without further ado, I present to you the project prototype. For acknowledgments, I would like to thank Professor Hewitt for the help and advice on my senior project. To all my professors in the department, I appreciate the dedication and commitment you have for student learning, and above all, the transferring of knowledge. And to the Department of Engineering Technology, I appreciate the understanding for the need to have a full rotation of night classes, which allows someone like me to achieve his goals and dreams. This concludes the presentation, and I will now gladly take any questions.